All right, on the back, we're looking at zeros, roots, and solutions. So all of these represent the same thing. They are all the point or points where the graph crosses the x-axis. Roots and zeros and solutions all are the same thing. They're all where the graph crosses the x-axis. So I call them a zero because if you plug in the x value, the f of x is 0. Like when I solved them out and I got a value, when I plugged it back in, I got 0. I can also call it a solution because when I graphed, sorry, not when I graphed, but when I solved my quadratics, we found the solution. We can also call it a root, which is kind of a weird name, but yeah, we call them roots, zeros, and solutions. So if I look at this graph right here, I can see that my graph touches the x-axis twice. Let me outline my x-axis a little bit more. There's my y-axis. So my parabola touches the x-axis twice. It touches it here and here. I just need to list the coordinates for those two places where it touches the x-axis. This is at 3, so I have 3, 0, and this one is at 5, so I have 5, 0. So those are my roots, those are my zeros, those are my solutions. It's just where the graph touches the x-axis. An x-intercept is a point at which the line or the graph intersects the x-axis. The way that I write it is for a point, I always put the actual specific value, like I did for the 3 and the 5, and then 0. For the x-intercept, the y value is always 0 because it's touching the x-axis. So the y-intercept is a point at which the line intersects the y-axis. So on the y-axis, the x value is 0, and then I have some specific number for my y value. End behavior. All right, so end behavior is what a function keeps doing after it leaves the graph. It represents the arrows on each side. And we always look at two specific values for x. I always look as x approaches positive infinity, and that's as x goes to the right. Where does the y go? I have 3 options. It can go up, it can go down, or it can go straight out to a side. And then my other thing that I look at is x approaches negative infinity, and that's as x goes to the left. Where does the y go? And I have the same 3 options for the y. It can go up, it can go down, or it can go straight out. I guess my arrow would point actually to the left if it's going straight out. These are my only 3 options. So if I look at my examples here, as my x's go towards positive infinity, that's going to be on the right side of my graph. On the right side, if I put a little arrow here, my arrow is pointing up. So my f of x, which is the same thing as the y's, are going up, which is positive infinity. If I look on the other side of my x's, as x's go to negative infinity, that's here. Let me go back. This was the right side. This is the left side. So my x's go to negative infinity on the left. That's going to be over here. My arrow is pointing down. So the y's go to negative infinity. If I look at this example, as my x's go to positive infinity, that's going to be on the right, which is over here. This is the right side of my graph, and my arrow is pointing up. So that's going to be a positive infinity. On the other side of my graph, as x's go to negative infinity, it's going to be on the left. This is the left side of my graph. My arrow is also pointing up, which will be positive infinity for the y's. In my quadratics, you'll only have two options. So for quads, they're either both going to go up on the left and the right, or they're both going to go down on the left and the right. Not a quadratic, so we're going to evaluate what happens on the left and the right, but in quadratics, these are your only two options. So we have an example down here where we're given a graph and we're going to fill in all this information. So let me come over here and put arrows on my parabola. So my domain for this, I'm going all the way to the left forever, all the way to the right forever. So my domain will be negative infinity to positive infinity. I use the parentheses because I can't actually hit infinity. For my range, my lowest value is going to be negative infinity because it's going to go down forever. But my highest value that I'm going to use is this y value right here, which is 4. It's actually using the number 4, so I use it as a bracket. My extrema, I'm either looking for a max or a min. So this point right here is my extrema. It's a max because it's a highest value. And the coordinate for that maximum value is negative 3, 4. My axis of symmetry is the vertical line that cuts my parabola in half. So this is going to be my vertical line that cuts my parabola in half. This x value is negative 3, so that is my axis of symmetry. Increasing and decreasing is using the domain, so I'm going to use a negative infinity and a positive infinity, and wherever my graph stops doing one thing and starts doing the other thing. So if I read it like a book, left to right, I first start increasing until I hit this point, and then my graph is going to be decreasing. So from negative infinity all the way to the left to this specific x value, negative 3, I'm increasing. That's my interval of increase. Negative infinity to negative 3. My interval of decrease starts at this negative 3 and it goes down forever to the right, forever to positive infinity. So I'm going from negative 3 to positive infinity. So I've cut my domain in half at the x value of negative 3. My y-intercept is where my graph touches the y-axis. I have one point where my graph touches the y-axis. That point is at 0, negative 5, so I just listed it out. For my solutions, also called roots, also called zeros, is where the graph touches the x-axis. I can see that the graph touches the x-axis twice. One time is right here, and that coordinate is at 5, 0. My other x-intercept is going to be this point right here, which is has coordinates negative 1, 0. All right, end behavior. I'm always going to look as x approaches positive infinity, which is on the right, and as x approaches negative infinity, that's on the left. So if I look over here, this is the right side of my graph. My arrow is pointing down. On the right side, my arrow is pointing down. On the right side, my f of x is going down. On the left side, as x approaches negative infinity, that will be the left side of my graph. My arrow is pointing down. So on the left side of my graph, my f of x value is pointing down. Rate of change. Another term for rate of change is, anybody? Slope. So it's nice to look at rates of change as things happen on our graphs, but my rate of change, I'm going to look from negative 3 to 0. These are my x values. So from negative 3 to 0, and then this one from negative 6 to negative 5.